Messy Jesse here with a Taramps DS800X2. This amplifier, the customer stated that they accidentally plugged it into a 1 ohm load bridged. I think they were testing some stuff outside of the vehicle on the bench and did a miscalculation. And they said it didn't even play any music as soon as they turned it on. It just decided to let go. The power supply section here is fairly burnt. I'm going to go ahead and take this stuff away from now. We'll clean this up at the end. Take a look at the board here. The board, I know, does have the bad power supply, so we're going to go ahead and take these off in a minute. I'm going to check and see what else may be bad here. And then what we'll end up doing is taking the oscilloscope and seeing if we get any PWM off the little chip here. I forget what this chip is named. The markings on that chip. Yeah, that's shorted, okay. That one's shorted. How about this side here? Are we shorted on this side? No? No. No. Nope. Not shorted there. Although this chip here might be open. Since it was in a bridged operation, when it did fail, I will be removing and replacing these as well with new chips. New transistors rather. Excuse my terminology there. So while we're here, let me just check the drive resistors, gate resistors. 5 ohm. 5 ohm, these survived. 4 ohm. And the last one here. No, maybe let me see, that is actually not the one I think I wanted to poke at. Give me 1 second. Oh, that was the one I wanted to poke at. Let's see if we get more. Try to get a better contact there. So that one appears to be gone. That one needs to be a 4.7. So maybe out of 4.7. May need to order some more. That's a 47K. 47R. I want 4.7. I am not going to put 10 of these 4K7. So I don't have 4.7 here right now. Okay. 4K7. 470, but not 4.7. So I will order some 4.7s and some 10s and some more, a larger assortment. So I won't be able to test that output into the transistor, that chip there for that particular pad, but I could check it for the other one here. See if the soldering iron is heated up yet. We'll give it a little bit longer. Which one of these were the shorted ones here? So it was that side, okay. Just verifying that it is this side. And this one does look like it's showing high on one of these components here. I am going to use the diode check to check some diodes real quick. Yes. Yep. Yes. Alright. We're going to go ahead and remove the faulty power supply transistors. Alright, we're going to get some pliers and get these out, these pins. This one just fell right apart on me. Alright, got one more to get out here. Now, if you're fixing a Taramps amplifier, you can contact them, and they will get you the parts. They will set you up. I'm down here in Florida, and we got some tropical storm off the coast out here, and everybody's worried about it coming in category 2 or 3 or something. I don't know. I'll just have to charge up a few car batteries and get my power inverter out. I can keep working. I might have to go back to recording this with just a single GoPro if the power is out, though, because I don't know how well that power inverter will like running all my computer equipment. What type of systems do you guys have in your cars? I have a little beater car that I play with, and I installed 2 18s and a 4th order wall. No trunk, no back seat, so it is a B-pillar wall. There's 2 McLaren 18s in there. They're a little bit old school. I got a good deal when I used to work at a stereo shop a long time ago. And I have an Orion XTR 4K on those. And they get down pretty good. My front doors are kind of crazy. I have 16 of the cheap Scar Audio 6.5s in each front door and 12 bullet tweeters. The 16 Scar Audios, 32 total, they're ran off a Sound Digital 8K, and it gets down. So let me know what you guys are running. I always like to hear different systems and different opinions on why everybody does things different. I don't think I'll go with 18s anymore. The impulse response or transient response is not there. They're good for like slopping some air around, but it won't hit a kick drum with the darn. It just sits and flops around. So I don't think I'll do 18s again, at least not for a SQ vehicle. In my wife's car, we have 410s behind the back seat. It's a pickup truck, a Ford pickup, smaller one, and they're ported, a little bit underspaced, but it sounds pretty good. The back doors are not done yet. The front doors have 3 digital designs, 8-inch, the mid-bass style, 1 digital design 8-inch, the mid-range style of their drivers, and then 1 1-inch phenolic compression driver and 4 bullet tweeters. And when I designed those doors, 2 of the bullet tweeters actually get muffled when the door is shut into the seat. That way you don't get a bunch of blaring highs. And that sounds really good. Everything's actively crossed over. There's Digital Designs 4.100, I think it is, for all 8 tweeters in the front doors. There is a Digital Designs amp for the 8-inch and the 1-inch phenolic. I ran a Taramps 3K for my 6 8-inch mid bass. There'll be one more mid. I just poked myself with the meter. There'll be one more mid bass going in the back door. So it'll be a total of 8 8s for mid bass, 4 8s for mid range, 4 1-inch phenolic drivers, and some tweeters. Sounds good. I haven't done anything in the pillars yet. I am thinking about doing something in the pillars to try to raise the sound stage. I'm debating on what tweeters I want to use up there. They need to be rather small, but they also need to have quite an output to keep up with the Pro Audio in the doors. So Peerless makes a couple tweeters that I've been looking into. Same with Dayton Audio and Morel. I don't know if I'll go with Car Audio brand or not on this yet. I'm not too certain. So one of these resistors look like it's seen much better days. I don't have that. That's a 4.7. That's okay though. So now that I got this shorted components out, 5620s, and we took out some power supply transistors. Sure, over here. 3205s. No, I don't believe the 3205s. I believe they're power supply transistors are 180N4 FB or F6. These guys, IRFB 5620, and it runs the 2092 chips that we're not going to be able to find right now. The diodes are M44, but I believe the marking is U2D on the diodes. So let's see, I'm going to just check over here. I forget where this gets its power from. I think it gets its power from 12 volts. Remote. Yeah, 12 volts. Yeah. Yes, it does. Okay. So we're going to get the oscilloscope up here on the screen. If it wants to play nice today. So once that scope's up, I'm going to go ahead and connect the ground, the positive, and I'm going to probe this leg here and check when I give it power if it wants to PWM. Oh, it did not. It gave me some weird signal there. Oh, there it goes. It's trying. Okay. So here, still here. Alright, how about over here? Now I'm going to remove that resistor that has a very low value because that may be causing... Yeah, I don't have PWM on this side. That's what's going to be causing that chip to be shutting off real quick, is this bad resistor, possibly, if it is the ground. Oh yeah, that resistor doesn't even have a leg anymore. I'll have to do a little bit of circuit board work on here, just jump one component will need to be jumped. So the PWM chip for this may be bad. I think I have one coming in for another amplifier though, so I'm not terribly worried about it at the moment. Okay, so we try to build there, but on this side we do not try to build. So I'm going to go ahead and check some resistance measurements here. From ground to this pin, to from ground over here, open. Open. So is this resistor not 4.7? No, this resistor is open. This is, or am I just not probing it properly? Let's check it. Okay, 4.7 meg. That's not supposed to be that high. So we will probe before that resistor and see if I have something. I still do not. Okay, then over here I do. Is this correct? Yes, it attempts to build PWM on one leg. The other leg, it does not. I assume this is the other PWM leg right here. Let's check this chip out and see. Yes. So this would be PWM on this leg as well. And it cannot output that. Okay. So I think this chip here has an issue as well, the driver chip. I do have another one coming. Let's check 2201. Now I'm going to go look on the spot for another board, 2201, because I don't recall that value off the top of my head. 2K? 2201 200? 2K. Okay, yeah. 2K. Well, this is shorted here. I think this one needs to be removed. 2201 down here is representing what resistance? 2202. Okay, so it is a 2K. I'm gonna remove this resistor here, the 2K, and we're now gonna check it's adjacent. Still not happy, huh? Okay, that's fine. I'm watching the scope here and I still don't see a PWM on that, so this little chip here has to be bad. We could check the we'll check the resistance again on these pads here and see if it's still giving us a very low resistance. Yes, 0.7. So I'm going to go ahead and remove this. Let's see here. Give me just a second. I'm going to go ahead and remove the IC that's down here with some hot air. Before I remove the IC, I'm going to put that one resistor back because I don't believe that resistor was the issue. Now that I checked the IC over here. With that not in circuit, I have a feeling it's the IC that's shorted. If not, we'll check and see what else could be shorted on the same path. So. Just sticking this little guy back on here real quick. Give me just a second. Then we'll move on to the next step, which will be taking that integrated circuit off the PWM controller for the power supply. Okay, that's back on. We'll get some hot air. I'm going to sit a little different here. Alright, then we're going to heat this little area up here and get this driver off. Now that that component is off, I'm going to check this resistance here to ground of this. There we go. Okay, so yes, that component was bad. Our little IC chip. We're going to get that underneath the microscope so you guys can see what chip I removed. Turn some light up here. Let's see. This is the component I removed. Let me see if I can get that in camera better. Very, very small. And this is the spot on the board that it goes. Let me see if I can. Alright, anyway, we'll go back to the camera. Cool, good enough. So, I believe I have another one of these chips coming. I can't do anything else until we put another PWM chip in there. That's fine. And then the resistor there, I'm going to use the actual through-hole component because the leg is damaged. It's carbonized, so I won't be able to get any solder to that. So that's all for this amplifier for now until I get some more components in for this, and then we'll continue. Thank you again. If you guys have any questions or comments, please feel free to leave it in the comment section. If you guys have any questions in regards to amplifiers and you need to get a hold of me, you can also check the comments for my Facebook link, or the video description rather for my Facebook link, and feel free to send me a message. Thanks for everybody else that helps me with this stuff. You guys know who you are. I give you guys shout outs every now and then. I'll continue to do so. It is greatly appreciated. It's hard to find a community that deals with this stuff. It seems like it's becoming less and less prominent for any type of electronic repair. Everybody just seems to throw their stuff away and pick up a new one. This is good for the environment, good for people learning, all kinds of stuff. So, and sometimes you simply can't get replacement parts. So I do fix other things than just amplifiers. I fix all kinds of random odds and ends. Keep checking back on the channel for different stuff. Take care, everybody.